ready. You can go.
We're ready?
Yeah.
All right. So, we did two things today. One is to look at what are called engineering drawings. And basically what they did is they were asked to create a structure of around 8 to 12 cubes, randomly like this. And then they drew the front view, right side view, and top view of their cube structures. They then took the original structure, hid it somewhere, gave the drawing to one another, and then the task was to reconstruct what this was.
Wow.
Yeah. And then you come back and look at the original and see if it's right. Okay?
Cool.
Yeah, it's very cool. It was new. Jared saw something like it over break, or over, summer camp, where things fall down, but it was hard for him. And I had to kind of push him to make more than a very, very simplistic image. He originally started with a 2 by 2 by 2 cube.
Sure.
Rather than something more complex like this sort of thing.
Right.
Okay? So that took a lot of brain cells for them to do. My instinct is that these challenge problems that would end the chapter on spacious solids, are on the hard side, and I think we should take a small break and do the beginning of the next chapter, which is negative integers, and then come back. I want to come back to maybe within the next couple of weeks we'll integrate and finish up the solids there. In general, the Beast Academy is timed to be about 3 weeks for one chapter, and the third of the 3 weeks is invariably the hardest, the challenge problems, etc. So that was half of the class. After break, this is the basic thing that we looked at, is why does negative times negative equal positive? Okay? And I can see Andrea beginning to tense her shoulders already.
I'm ready to learn this.
So, in order to understand it, we need a situation. Oops, I forgot a pencil. You don't happen to have anything? Okay. I'll just say it verbally then. Perfect. We need a situation in which there's a reasonable way to have an equation that is involving multiplication, and it also has to be so that each of the 3 variables could be interpreted as negative or positive. So there are a few different ways of doing it. This is the way that I kind of like the best. Rate times time equals distance. So they kind of know this formula, at least intuitively. If you go 3 miles an hour, 4 hours from now, you'll be at the 12-mile marker, okay? But now the more interesting thing is, how can each of these quantities be expanded and thought of in a negative way or a positive way? So here we go. We have our little house here. We have a number line. This is 0, -5, -10, -15, 5, 10, 15. We have a bunny rabbit named Bernard. Right now, Bernard is at 0. Okay, so here we go. Speed. Well, Bernard could go 5 miles an hour, okay? Or Bernard could go -5 miles an hour. He's just going backwards. That's all. Just
Direction.
Yeah, is he going this way or is he going that way?
Okay.
So that's an intuitive understanding of how Bernard could be going in a positive direction or a negative direction. Okay? Time. Andrea, you have a question?
That's direction, though. That's not.
That's rate. The rate is the number times the direction.
Which is already doing a positive times a negative.
Well,
Sort of.
that's how the vector of rate is normally thought of. It's a
Right.
directed vector. Okay. Time. When we say that Bernard goes 5 miles an hour, 2 hours from now he's at the 10-mile marker. That's good. But if you look at the house and you see Bernard going this way, you could also, and if you presume he's going at a constant rate, instead of asking where will he be 2 hours from now, you could also ask where was he 2 hours ago? And so even though he's going in this direction, 2 hours ago, he must have been here at -10. So now we have an understanding of how time could mean time forward or time ago, time backward. Okay? And distance is the easiest one. Bernard could be at the 5-mile marker, or he could be at the negative 5-mile marker. Okay? So now for each of these three quantities, we have a way of interpreting each of them so that they could reasonably be positive or negative. With the kids, we did all the, many permutations. We'll just give the killer one for right now. Here we go. If Bernard is going 5 miles an hour to the left, in other words, negative 5 miles every hour, okay, where was he 3 hours ago? You look right now, you see him right here. He's going 5 miles an hour. 3 miles from now, he'll be here. But where was he 3 miles ago? He was over there. So negative 5 times a negative 3 is a positive 15. It's wild. Okay? So there are a few other examples that have this same structure. Something times something equals something. So for example, we can talk about a bank account in which you make a deposit or make a withdrawal. You can deposit a positive amount or you can deposit a debt, so to speak, some kind of an IOU. And then how much money do you have or how much money in debt? There are situations with elevators going up and down the floors, and so you can kind of make up examples in which each of these three are positive and negative. This is the one that I like the first. It seems the most intuitive. Okay, it's an interesting one. It's an interesting time because, as Andrea's anxiety indicates, a lot of people can memorize that fact. You can get a first grader to say negative times negative is positive, but that doesn't mean they know what it means, right? And we're kind of at a crossroads that as the further they go in math, it's easy to start gobbling down rules without knowing why they're true. So for them, I tried to be a little bit dramatic with them and told them if they ever have a math rule that they are told to do or that they think they're supposed to do, in homework or in life or something, and they don't know why it's true, they are to treat it as a medical emergency and phone me right away. So I've had students phone me, 10 o'clock at night or whatever, it's fine. But I want to get an ethos that we don't just accept rules and blindly follow them, right? That also buys into their desire to be rebellious anyway. So we'll get a 2 for 1. Yeah, and it's interesting that this is the first one which is not intuitive. Like everything else, you can kind of, but this is the first big one where it's going counterintuitive. Yeah.